Hello, everybody. Welcome to the presentation on the Illyrian wearable oximeter. And I'm Jim Rutler. I am co-founder of Aithre, for those of you who don't know me. And today's presentation is going to cover the Illyrian II, what it is and how to use it. Share my screen here, the PowerPoint, bear with me. All right, so as I indicated, the Illyrian II is a haptic safety wearable, an oximeter and gyroscope and altimeter all in one. It has multiple sensors and outputs blood oxygen, heart rate variability, sampling quality, head movement, cabin altitude, and it uses USB power with wireless data. There's an asterisk here because at the end, I will give you a preview of a future product that will operate on a purely wired basis for more reliable data. The components of the Illyrian II include the case, as shown on the right, and the pad. The case has the electronics, the processor, the sensors, and the pad is remotely positionable on the forehead or under the ear. There's a lot of confusion as to where you use the Illyrian II and where the pad is located to get the best readings. There are two approved locations and only two for the Aithre Illyrian II. One is low on the forehead as indicated, and the other is in front of and below the earlobe as indicated on the left and right. Either the left ear or the right ear may be used. It is not reliable to position the Illyrian pad on your wrist, on your cheek, on your earlobe, behind the ear, high on the forehead. The Illyrian II will give unreliable readings when it is used in locations other than those which are depicted. Examples of how to wear the Illyrian are shown here. That's me in the middle, and I'm wearing the Illyrian II underneath my ear cup, directly in front of and below the earlobe per the drawings. I prefer this location because it keeps the Illyrian II out of the way. The case is mounted on the back of the A20 here, but that works as well with the A30 or the Lightspeed variants. In addition, the Illyrian II is shipped with a headband as depicted on the left, and that headband includes a pouch. So this is common for folks who may not get reliable readings on the cheek area. You can position the Illyrian case in the pouch and the pad underneath the headband, low on the forehead as depicted. Couple of kind of notes in terms of placement. Commonly, people will call and they will complain about unreliable readings, and it will oftentimes be resolved by a relocation of the pad to the more correct or to a correct location. On the forehead, people tend to use the Illyrian pad a little too high. It needs to be low and just above the eyebrow. When it's high, you're not going to get good readings because there isn't good blood flow high on the forehead. So it needs to be lower than you might expect, and you need to, and I'll show you how to verify in the app its location and the quality of the readings that are being obtained from that location. Likewise, when people use it on the earlobe, or in front of the earlobe, there's a common misconception that the sensor ought to be located on the earlobe or behind the ear or directly under the earlobe, and it doesn't work in those locations. The readings will be unreliable. The location, as indicated in the picture in the middle where I'm wearing it, is in front of the ear, low and kind of parallel with the earlobe, but low and adjacent to the earlobe, but high up on the cheek. In the tender area in front of the ear, there's a lot of good blood flow there, and the sensor has been tested and built for these two locations. If you wear it anywhere else, you're on your own, and we can't attest to the reliability of the readings in other locations besides these two. Once positioned correctly and powered with the USB power cable, the readings come and the outputs come in four forms: haptic, which is native to the Illyrian II itself; wireless via the Aithre Connect iOS app; wireless via the HealthView 1 and the HealthView 2, as well as wireless to the Garmin Dynon advanced avionics systems and others via the Shield EX 3.0. I will discuss each one of these in turn. First and foremost, the Aithre Connect iOS app is a very reliable way to present a comprehensive set of parameters associated with the Illyrian II. As the bullet points indicate, it's a reliable, fast communication. Every 12 to 15 seconds, parameters are updated. There's automatic pairing via the BLE. You can use it with your iPhone or your iPad. It can be in the background or in split screen. The SpO2 and the other parameters, such as heart rate, movement, heart rate variability, cabin pressure, altitude, all of these update every 12 to 15 seconds in the app. And you can pair up to 6 Illyrians at one time, with ordering of the pairings controlled by the order that they were first powered on. I will show you how to repair those if they're incorrect, but if you have one, it will show up in pilot position. If you then connect the second, it will go to the co-pilot and so on, unless they are reordered and then repaired. There's trend graphing, and there's relays from the Aithre Connect app to the HealthView and the Shield EX 3.0 to the Garmin Dynon and Advanced to reinforce the data and speed up that otherwise possible lag time independent of the app. I'm going to change the screen sharing to an iPhone mirroring with live data that is being demonstrated by Zoo, who is wearing the Illyrian II and has been wearing the Illyrian II during the presentation. You can see her in the window, and she's got it in her preferred location on the forehead, low on the forehead. Okay, here we're demonstrating live Illyrian data being read by the Illyrian II that is worn by Zoo. I'll change the name here to reflect that Zoo is wearing the Illyrian, and it is showing a 98% blood oxygen level, which is appropriate for the altitude. We're at sea level or just a few hundred feet above sea level. So it's a high blood oxygen reading on the ground. We've got a heart rate of about 80. Cabin pressure is detected by the onboard pressure altimeter, 600 feet. Weather dependent. Head movement, as you can see, is oscillating as Zoo moves her head. There is real-time movement indications, and that is on a scale of 0 to about 1,000. So smaller movements will yield a lower head movement than larger movements. Heart rate variability, which is the variation in the time between successive heartbeats in milliseconds. Within the app, you're getting your blood oxygen level in the blue bar, the heart rate indicated with the red bar, and a quality indication with the green bar. Typically, when people are unfamiliar with the Illyrian II and first use it, they skip over the quality indication in the green bar. But this is the most important field to become familiar with when you first begin using the Illyrian. The reason why is the quality indication is a direct indication of the amplitude of the signals that are being detected with the pulse oximeter. The higher the amplitude, the stronger the readings are, and the more reliable the blood oxygen level and the heart rate are. Once you've identified the location that yields high sampling quality for yourself, you don't have to concern yourself with the sampling quality as much as you do when you first begin using it. Oftentimes, people will choose locations that yield low quality indications here, and they'll never modify their location or move the location to adjacent positions on the forehead or the ear, which would result in much more stable readings. The quality indication should be fully deflected. Oftentimes when you're cold, you first put it on, the amplitude of the signal strength is a little bit lower, and it may kind of oscillate between 60 and 100 before going up to 80 to 120 and beyond. The idea, though, is that you don't want to have the quality indication low. It should never be 0 to 40 or 0 to 50, and it also should not be oscillating between 0 and 120 or 0 and 80. It should be stable and consistent and high. High on the bar graph meaning above 80. If you have good quality indications, then your SpO2 readings and your heart rate readings will be reliable. If your quality indications are low, then you need to move the sensor pad, the blue sensor pad, to a different location until you find a place where the quality is high. As you can see, Zoo has been wearing the Illyrian for about 15 minutes, even prior to the presentation being started. And in that 5 minutes, she has only dropped one reading over 12-second intervals in the entire 15 minutes. Otherwise, the blood oxygen level has been very stable, shown in blue at near 100. The heart rate has been fluctuating, as indicated by the heart rate variability, but all within a normal range. The altitude has been stable, and the head movement is oscillating based on regular anticipated movements for the type of posture that she is engaged in, which is watching the presentation. If you're more active, the head movements are going to be, there's going to be more variability. Otherwise, it should be stable as it is here. A couple of notes, kind of some advanced settings are found here in the settings tab directly above where it is indicating blood oxygen level. So if you hit that drop-down menu, there's a number of hidden fields and settings that you can adjust for how the Illyrian II operates. Set the warning level for what these two settings at the top, the blood oxygen level and the heart rate, are the warning levels that trigger a pop-up notification or a Siri notification to your headset when that threshold has been crossed. So I've got it at 92%. That means if the blood oxygen level dips below 92%, you will get a warning. The lowest you can go there is 85%. The baked-in notifications that are kind of default for the app are 92% and 85%. You can set this additional one for a third point that you're notified to keep you alert and aware of what your blood oxygen level is during flight. The heart rate warning level is, as it sounds, it is a warning level for Siri or a pop-up notification within the app when your heart rate exceeds a particular level. Typically at rest, your heart rate is around 40, 50 on the low end to 60 to 70 on the high end. During flight, during stressful events, it's very common to have your heart rate surge, for example, on takeoff or on an approach, or any other stressful condition during flight. Your heart rate may surge beyond 100, 110 beats per minute, which you should be aware of because you can take steps to calm yourself down, deep breathing, with movement, and with focus. Additionally, oxygen and delivery of oxygen is another way, another mechanism to lower your heart rate if needed. The haptic intervals are settings that pertain to the vibration of the Illyrian II case. So the Illyrian II case has a haptic vibration motor that is activated when particular thresholds have been crossed. And you are in charge of what those thresholds are and whether or not that parameter is engaged. For example, the heart rate above 110, this is the vibration period, or the threshold that the vibration will begin and the haptic notification will begin, which is independent from the Siri notifications. That here is set for 110 beats per minute, and it is turned on. As indicated, when that threshold is crossed, you will receive 2 vibration haptic notifications. Cabin temperature. If the cabin temperature exceeds whatever this threshold is set at, you will get an indication. But here, that parameter, or that haptic variable, has been turned off. You'd need to turn that on in order to receive that notification. In addition, the cabin temperature is tied to the Shield products, any carbon monoxide detector. If you do not have a Shield product paired to the app, the haptic notification for temperature will not work because that temperature reading is obtained from the Shield. Carbon monoxide, if you have carbon monoxide above a particular threshold, typically during flight you will receive, or it's common to encounter between 0 and 10 parts per million. So if you put this at 10 parts per million and you turn it on, you will receive a haptic notification of 3 vibrations if the carbon monoxide goes above 10 parts per million. Likewise, blood oxygen level, independent of Siri and pop-up notifications, a haptic vibration of 3 vibrations will be presented if the blood oxygen dips below 92%. Cabin altitude. This is particularly important for a pressurized aircraft like a TBM or a Pilatus, or Meridian. If you're flying and you expect the cabin altitude to be maintained at 10,000 feet, but it goes above 15,000 feet, you can set vibrations for that depressurization event, and the vibrations will be 4. And then the movement level. If your head movement is not active, you can set a threshold where you will receive a 5 vibration, the maximum number of vibrations for lack of head movement. This is designed to have the maximum impact and notification with multiple vibrations that are repeated. Now, how often are these vibrations presented? Well, that's controlled up here at the very top. The maximum is once every 3 minutes you will get whatever number of vibrations in series. So here we've got every 3 minutes we would get a heart rate notification above 110. We get 2 vibrations if that occurred. If we want that to be more frequent, we can drag that back down to as little as every 20 seconds, which is just about the refresh rate for the data. And the head movement, this is a little bit different, but this is how often do you want that threshold of head movement to be crossed? So how active do you need to be in order to trigger that head movement? Here, this is set for a head movement of at least 275, as indicated below, every 3 minutes. And I've turned it on so I would get vibrations every 3 minutes if the head movement has not exceeded 275. And that unit is a bit arbitrary, but it's based upon, down below here, if we close these, right below here, it is based on this value. Again, the range is 0 to 1,000. If you really push it and you do like a full 180 turn, you can get it to approach 1,500. The typical ranges would be somewhere in the order of 100 to 300. And it really depends on how your typical behavior is, your behavior patterns during flight, and maybe what phase of flight that you're in. So you can adjust those. But in cruise, you should have, at high altitudes, you should have some period of movement every few minutes, and that should, and that will, by monitoring that, it will alert you if your head movement has not crossed the threshold and you need to be woken up, for example. Okay. There's also a graph down below which I pointed to early on, and that graph plots SpO2, a quality indication, your heart rate, your pressure altitude, and your heart rate variability over time. You can zoom in. It's harder to do here on the computer screen, but with your app, you can pinch and zoom. And this is helpful for diagnostics. For example, if your pressure altitude is climbing, but your blood oxygen level is decreasing, you can identify perhaps that your oxygen system is not working as you would expect. Or if the quality indication is low and your SpO2 is low, well, that can indicate that you did not have a good position for the oximeter when those readings were being taken. You can clear the graph and begin over here. And I want to show you that there are more Illyrians that you can pair up in the app. As you scroll down, you have 1, 2, 3, up to 6 different positions here, and they are for if you have multiple Illyrians, you can pair them up sequentially. Now, after you've paired them up the first time, the location in memory is recalled. So if I then paired up a second Illyrian here, it would show up here in position 2, and Zoo would remain in position 1. If we disconnected both, then you could pair them up in any order you wanted. Zoo is Illyrian, the current physical unit she is wearing, would always show up in position 1. That would be the pilot Illyrian. You can reorder that by going to the settings from the home page, top left corner, by clearing the devices and then repairing them and providing power in the order that you want the Illyrians to be present and presented. On the home page, there's also an indication for the pilot, blood oxygen level, and heart rate, and you can access the expansion page here where you can get more information. Okay. Now that we've indicated what a good reading looks like, Zoo is going to move the Illyrian II high on her forehead to show you how the sampling quality will change with a different position. You can see from her camera that she's positioned it higher, and the quality indication is now oscillating. It went to 0, it went back up, and now it's settling in at a much lower value. The readings are averaged over a minute period, so there's a trailing average of 5 to 6 readings that are required before you'll notice a measurable decrease in your blood oxygen level to smooth out the blood oxygen indications despite talking or movement of the pilot's head. But that means that with low quality indications, you're going to begin seeing low blood oxygen level and irregular heart rates within about a minute. And if you have bad readings, it will take a few samples before those readings then get corrected. You can see here on the app that there's low quality and that the quality indication is oscillating between 0 and 60. Now, Zoo, go ahead and reposition it back to the preferred location that works well for you. And you can see that the quality indication has bumped up. It's now settling in at a much higher, fully deflected indication, which will yield very reliable and consistent readings for many hours during flight. Okay, I think that will be it. We're going to close this down. I do want you to remember that quality indication because I'm going to refer back to that when we talk about the HealthView 2 and the Shield EX3 outputs to the Garmin. Okay. Thank you, Zoo. We are going to return back to the presentation. The HealthView 2 is another output. The benefits to the HealthView 2 over the app are that it allows for customizable presentation of the blood oxygen level and the heart rate relative to other gauges. For example, as depicted here on the HealthView 2, we've got blood oxygen level presented with heart rate, carbon monoxide, respiratory rate, flow rate of the oxygen, and oxygen pressure. All of those are fully customizable in the HealthView 2, and I will demonstrate how to do that. So you can arrange the fields as you want. The data is received via Bluetooth Low Energy, independent of the app or the pilot. If you have the app open, optionally, it's not required, but it will reinforce the signal of the BLE, and it will reduce any lag time and support more Illyrians. So you will get BLE will provide the pilot information only for blood oxygen level and heart rate. If you open the app and run it in the background, either in split screen, background mode, but you have it open and paired up to the Illyrian, and the Illyrian is in position of the pilot and the co-pilot, as correct as you expect, it will automatically relay that information to the HealthView 2 to supplement the BLE data that is received directly from the Illyrian 2, so that you have two channels of data being packaged and received by the HealthView. The result is that you will get no lag time and a near real-time indication of your blood oxygen level and heart rate updated on the HealthView 2. As I said, there are a couple limitations without the app, is that you may experience a lag because the Bluetooth Low Energy, that is fairly reliable, but there are periods where it is dropped when it's not used with the app. And there's no real-time signal quality indication without the app. These two limitations make it currently important to run the app, the Aithre Connect app, even if you're not actively using it, run it in the background, because it will allow you to position the Illyrian correctly and to have the data reinforced and relayed so that it is always fresh on the HealthView. I'm going to open up a camera view of a demo HealthView 2, and I will show you exactly how to set up the HealthView 2 and where to get the readings. Okay, hang tight while I get the camera. Is it when you hand me the camera, please? All right. We're looking at the HealthView 2 with the ATD57. There are three variants of the HealthView 2 ATD. There's the 11, which is the portable square variant. The ATD57 is the 2¼ inch dial, and the ATD80 is the 3 1/8 inch dial. So the ATD57, the 2¼ is what we're looking at here. And you can see the blood oxygen level is presented here for the pilot, and the pilot heart rate is here. To set this up initially, you hold that inner knob, push it, and depress it for 3 seconds, open up configuration mode, go to HealthView, make sure that you've got the number of passengers in the aircraft set, and go to installation, go to system. First, make sure that you've got an Illyrian configured. If you don't have an Illyrian configured, you're not going to receive any data for the Illyrian. So you need to let the ATD know that you're expecting 1 Illyrian or 2 Illyrians, what have you. Hit done and back out. And it will ask you if you want to do the auto layout, and you should do this initially. So you hit the inner knob, the layout will be generated automatically to accommodate the Illyrian, which you've now configured. And when you go back to page, you will get the Illyrian 2 to show up here, which it was already configured for the Illyrian 2, and that's why it's presented here. If you want to modify the location, hold the inner knob, we'll open up configuration mode, go to the HealthView, go to the installation, go to layout, and go to the page where you want to depict or present the blood oxygen level and the heart rate. Go to the field. Here it is, pilot. There are 3 bars on each page and 4 boxes. Here's the box that has currently the blood oxygen level. You can change a different one. Say we want to put the blood oxygen level in box 3. We can do that. You scroll through one of the 60 fields that is available. and you find the Illyrian SPO2 for the pilot or co-pilot if that's what you prefer. We could do that here. And then you escape, 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 escape all the way back through the menu, and you are returned to the home page, which you now have presented your pilot and passenger blood oxygen level. And you can modify the pages. You can add up to 9 pages. You can have dedicated pages with just the Illyrian data. Other data that you can present that's associated with the Illyrian. Let's look at that. Going back to page 1 again. For the pilot, other options are SpO2, heart rate, and that's it. So that's a limitation of the HealthView 2 is that, again, you're not getting quality indications currently, and you're not getting head movement, cabin pressure altitude as measured from the Illyrian 2, or heart rate variability. So all those parameters are coming into the app, and it's a good idea to keep the app open, not only for the relay, but also for the additional information that's presented there. Okay. Going to return back to the presentation mode of the PowerPoint. If you've got the Shield EX 3.0, it acts as a data relay for the blood oxygen level, the carbon monoxide level, and the oxygen tank pressure to the Garmin, the Dynon, and the advanced and many other avionics systems using analog voltage outputs. All of these are native. Analog voltage outputs and inputs are native to each of the engine monitoring modules of the Garmin, the Dynon. These are the GEA24 and the SVEMS. These modules accept analog voltage inputs, which are output by the Shield EX3. The Shield EX3 gets the 3 pieces of data, the blood oxygen level, the carbon monoxide, and the oxygen tank pressure in different ways. The carbon monoxide is native to the Shield itself. The Shield itself reads carbon monoxide data and outputs it directly, and so the data is very reliable because there is no wireless interface between the carbon monoxide data and the EFIS. However, the blood oxygen level and the oxygen tank pressure are gathered using BLE automatically from the Illyrian and the Meso, which is the oxygen tank pressure sensor. That data is then received wireless and repackaged into an analog voltage output that is then passed through the engine monitoring module to the Garmin. The reason why this is important is because there may be a lag time experienced with the blood oxygen level and the oxygen tank pressure that sometimes can be annoying or to an extreme can be unsafe. Moreover, there's no way with using just the Shield EX3 to monitor the quality indication or the other parameters that are present for the Illyrian 2, like heart rate variability, cabin pressure altitude, and head movement. So, like the HealthView 2, if you run the Aithre Connect app on your iPhone or the iPad, split screen or even background mode, as long as the device is not off, the app will act as another relay of the data and will improve the refresh rate and decrease the lag time to a much lower level, every 12 seconds typically. So you'll get more reliable data. In addition, you will be able to monitor the quality indications to ensure that the location on the Illyrian is correct, that the pad is positioned in a good location to yield good results. So the recommendation is to use the Aithre Connect app in the background, even if you're not actively monitoring it, because you'll get the notifications, you'll get the relay, and you'll have the ability to look at it if you have a low indication of blood oxygen level to double check the readings to make sure it's not stale. and that it's actually current, and that it's actually based on good quality indications. I will now, I'm going to share the instructions and the location of the instructions so that you know how to set this up. The Shield EX3s are very popular, and most new panels that are made in the United States for most aircraft include a Shield EX3 as a carbon monoxide detector. So if you're interested in getting that information onto your EFIS, you may already own an EX3. If you do not, it is very easy to install it. I'll show you how. Okay, that's not the correct screen. Let me go back. I'm going to reshare the web browser. Okay, let's see here. Looks like it's not pulling up. I will share my whole screen, and I will just open it up directly. Okay, close this. I will open up my browser, and here is our home page for Aithre. There's a hamburger menu in the top left. Access product instructions there. All the instructions for every product are organized neat and tidy right here in one location. Scroll down to the Shield EX3 product, which is down about halfway. There we are, Aithre Shield carbon monoxide detectors. And you want to look right here at the Aithre Shield EX2, 3, and 3.0S installation instructions. The EX2 has been retired, so the EX3 and the EX3S are the two options right now for the Shield products. Jump to page 5. Gives you the wiring information for it. Essentially, it is hookup power to 5 to 28 volts. The power draw is very low. The current is 5 milliamps, which means that you can hook it up directly to an engine monitoring pin. Typically, there's a few 12 or 5 volt pins available with a 50 milliamp limit, which the Shield meets that limit. So you can hook it up to like the Garmin G3X, the Dynon power pins, or you can hook it directly up to the aircraft power after the avionics switch. The black goes to ground, and the white, yellow, and blue wires are the analog outputs for the various data points. Today, we're talking about the Illyrian, so that's the blue wire, and the blue wire is covered here. It requires the Illyrian II. It outputs a 0 volt for 0% SpO2, and 100% SpO2 is found or is indicated when the voltage output is 3.3. So the linear voltage output ranges between 0 and 3.3, which yields 0 to 100% SpO2. All you've got to do is hook that up to the Garmin G3X or the Dynon SVEMS, or if you have advanced, it is to a serial port, and that's the one model that uses the EX3-S. There is another configuration where you can use the EX3-S with an ATD for kind of a HealthView Lite, which features carbon monoxide, cabin temperature, heart rate, and blood oxygen level only, and with no oxygen system information. So no turbo, no AVI. It's a HealthView Lite. And that one requires EX3S, as does Advanced. But Garmin and Dynon, you use the EX3 without the S. S stands for serial. And the EX 3.0 outputs analog voltages. And that's what most people are using. The instructions for each of those is found in an addendum beginning on page 11. There is an addendum for advanced. Again, advanced uses data input, either number 2 or number 1 RS32, 232 inputs or 0. Those are here on the backup EFS harness. You can find those. You just hook it up to the correct pin for that input. Then you go over to the advanced. There's a screenshot. You choose the port that you hook the pin up to. You choose Aithre Integrator. Then you go to the cabin environmental, you choose carbon monoxide detector, and you choose the Aithre integrator via the RS-232. It's that easy. If you do that, you will get this data presented in a dedicated panel, which is nice. Carbon monoxide, oxygen tank pressure, blood oxygen for the pilot, and heart rate for the pilot. The data here again is fed via Bluetooth low energy for the pilot, heart rate and blood oxygen level. If you want to have more reliable information presented here, all you have to do is open up the Aithre Connect app and make sure it's paired to the Illyrian. It will automatically relay the data to the EX3, which will then pass it off to the EFIS, and you will have updates every 12 seconds using the app to monitor for your quality. Dynon is the next addendum, which is found on page 16 of the PDF or page 15 if you're looking at the document. It's labeled addendum B. The Dynon is just as easy. There are 4 recommended pins that you use, 8, 22, 23, and 31 of the SV EMS module. If you cannot use those pins, well, then you can use these other non-enhanced pins, which there are more of. But the non-enhanced pins will require an additional configuration step, which I'll reference in just a minute. So the preference is to use one of the enhanced pins, 8, 22, 23, and 31. In addition, you've got to make sure that you have the most recent Dynon sensor file. Fortunately, Aithre is native to the Dynon sensor file as of about a year ago. So if you've got the most recent Dynon sensor file, which is available with every new Dynon upgrade, then you do not have to do anything except for physically set up the pin, and then you navigate right here you go to the engine monitoring system setup page, you enter sensor mapping menu, navigate to the sensor pin, and then select pressure sensor. I know this is a little bit unusual, but everything in Dynon that is analog is labeled pressure sensor. So you want to select the pressure sensor first. This is a step that sometimes people miss. And then you have to set up the function of that pressure sensor, and this is where you choose carbon monoxide or oxygen or SpO2. If you don't do these 2 steps, oftentimes you have irregular data presented or the ranges will be off. You might have a 0 to 2500 output as opposed to a 0 to 100 or a 0 to 25, 250, depending on which function a default went to. So make sure that you've chose pressure sensor for the blue wire and that you have chosen SpO2 as the function. And you have some additional options within Dynon to make it a different style and size. Screenshots are here, so you have something to look at. Once you've set up, this is a carbon monoxide example, but you can set the alarm whether it is on or off. You have the maximum value and the minimum value here, whether or not you want to have the units depicted. And then you can choose color ranges for each of the levels. Here between 41 and 300 for carbon monoxide, there's going to be a red bar. Now, this is analogous to how you would set up the blood oxygen level. The only difference would be the range would be 0 to 100, and you might set up the normal between 92% and 100%, the red between 85 and 92, I'm sorry, the yellow between 85 and 92, and the red below 85. If you continue scrolling, there is an example of what the gauge will be presented as. In this case, it's an engine type RPM style gauge with carbon monoxide labeled and a readout, a text discrete readout of 23 parts per million that corresponds to the position of the needle on the graphical gauge. Continue scrolling. There is this additional step. Typically, this is not required, but if you are using a non-enhanced pin, then you have to do this additional step, which involves going and getting the high and the low value on startup of what's being shown on your EFIS, and then communicating with us here at Aithre will help set that file up to give you a correct calibration. If your Dynon is outputting 0 normally, and 255 parts per million on startup for carbon monoxide, and 0 for blood oxygen level, and 100% on startup, and then whatever the current reading is when you're wearing it. If the values are all as you would expect, then there is no need to go into this additional step. This is only required if you're getting a default reading of like 3 and not 0, or you're expecting 100% blood oxygen level, but you're instead getting 103%. And this will help calibrate that down to the more expected 0 to 100 range. Now with Garmin, it's a little bit easier. There's a lot of pins on the GA24. You just need to choose one of the general purpose pins. Like for example, position 7, GP7 is an example. That is physical pin 29 on the GA24. You can choose any one of these pins here in the engine information configuration setup, position 1, GP1, GP2, GP3, and so on through GP7. One of the GP1 through 7s. And then you have to go figure out which pins those correspond to, because the pin 1 does not correspond to physical pin 1 on the GA24 DSEB connector. So you have to figure out what that mapping is. If you're trying to hook up pin GP1, you have to go find where GP1 is. And here it is, position 1, that is physical pin 19. Then when you go to the menu, you choose position 1, tap on it, and that will open up these pages. You would choose custom analog, and then you would hit the calibration down here, and you would set the ranges up as 0 to 255, and then make sure that there's a linear graph output. And that's it. There's a few other things that you can do where you can choose ranges and the name that you want to display, and whether or not you want it to show up automatically on the EFIS. Okay. Stop. Actually, I can go right back to the presentation from here. And we'll go to the final slide, improvements on the horizon. I thank you very much for attending this presentation and putting the effort into learning how to use the Illyrian. There are many thousands in the field. It's not a new product. It's been out since 2017. And in fact, 1 year, one product of the year by Aviation Consumer Magazine. It's a reliable product, but it does require a little bit of effort to make sure that the placement is correct and that you're using the technology the way that it's designed to be used. However, there are limitations, and as always at Aithre, we're making improvements. And one of the improvements that we're actively working on is an improvement to the Illyrian. Namely, we're going to output the data via hardwired connections to both the Garmin, the Dynon, the Advanced, as well as to the HealthView. With some of those technologies, including the HealthView 2 and the ATD, you will get more data presented, including the quality indications, the heart rate variability, the head movement, the blood oxygen, and the heart rate information, all in near real time. So it will be a substantial improvement over using the Bluetooth Low Energy and using the app. Stay tuned. We expect to have more on this and at least the availability of the product by Sun and Fun and Aero 2026 next year. I'm Jim Rutler for Aithre. Thank you to Zuzana, co-founders of Aithre. If you have any questions or concerns, or you want to talk through any problems that you're experiencing, please don't hesitate to reach out or email us, Jim at Aithre Aviation, or Zoo, that's Zulu Uniform at aithreaviation.com. Thank you. Have a good day. Okay.